Welcome back. In today's video, we'll learn about one of the earliest and most important types of automobile transmission systems, the sliding mesh gearbox. We'll cover sliding mesh gearbox definition, main parts, working principle, advantages, disadvantages, and even a few real-world applications. A sliding mesh gearbox is a transmission system that allows the driver to select different gear ratios by sliding gears along a spline shaft using a gear lever. In this design, the Layshaft gears are fixed, while the gears on the main shaft can move or slide to engage with the Layshaft gears. Although this type of gearbox is now considered obsolete, it played a vital role in early automobile engineering. It was first introduced in 1894 by Louis René and Émile Levasseur, who developed a 3-speed sliding mesh transmission system, marking the beginning of modern vehicle transmissions. Now, let's take a closer look at the main components of a sliding mesh gearbox. There are 3 main parts of a sliding mesh gearbox: shafts, gears, and the gear lever. Shafts transmit power through the gearbox, connecting the engine to the wheels and enabling the vehicle to move at different speeds. They form the backbone of the gearbox, allowing torque and motion to be efficiently transferred between gears. There are 3 types of shafts. Clutch shaft. This shaft receives power from the engine when the clutch is engaged. The gear mounted on it transmits motion further into the gearbox. Layshaft, or countershaft. This shaft connects the clutch shaft to the main shaft. The gears on the layshaft are fixed and remain constantly in mesh with the gears of the clutch shaft and the main shaft. Main shaft. The main shaft serves as the output shaft of the gearbox. It receives power from the layshaft and delivers it to the drive shaft. The gears on the main shaft are internally splined, allowing them to slide along the shaft to engage with the corresponding gears on the layshaft and achieve the desired gear ratio. In a sliding mesh gearbox, the gears are responsible for transferring power from the engine to the drive shaft. They also provide different gear ratios, allowing the driver to control speed and torque according to driving conditions. There are 2 main types of gears used in a sliding mesh gearbox. Spur gears. These gears have straight teeth and are simple to manufacture. While cost-effective, they can be noisy at high speeds. Helical gears. The teeth of these gears are angled, allowing smoother engagement, quieter operation, and a higher load carrying capacity compared to spur gears. The gear lever is operated by the driver to slide the gears along the main shaft, allowing the selection of the desired gear ratio for different driving conditions. The sliding mesh gearbox works by transferring power from the engine through a series of gears and shafts, allowing the driver to select different speed and torque ratios. When the clutch shaft rotates, it drives the corresponding gear on the layshaft, causing the layshaft to rotate in the opposite direction. The gears on the layshaft are fixed, while the gears on the main shaft can slide along splines to engage with the required layshaft gears. The selector fork, controlled by the gear lever, moves the gears on the main shaft into the correct mesh, allowing the gearbox to provide the appropriate gear ratio depending on driving conditions. An idler gear is included for the reverse gear, which changes the direction of rotation of the main shaft, enabling the vehicle to move backward. To better understand the working of a sliding mesh gearbox, here's how power is transmitted in each gear. In first gear, the smallest gear on the layshaft meshes with the largest gear on the main shaft. This provides maximum torque at very low speed, ideal for starting the vehicle or climbing steep surfaces. In second gear, a medium-sized main shaft gear engages with the corresponding layshaft gear. This delivers moderate torque and a higher speed compared to first gear. In direct drive, the clutch shaft is rigidly connected to the main shaft through a dog clutch. This configuration allows both shafts to rotate at the same speed, ensuring maximum transmission efficiency with minimal power loss, as no gear meshing occurs during power transfer. For reverse, an idler gear is placed between the layshaft gear and the main shaft gear. This additional gear reverses the direction of rotation, allowing the vehicle to move backward. The sliding mesh gearbox offers several advantages. Only one gear is engaged at a time, which reduces vibration and fluctuating loads on the shafts. It provides higher mechanical efficiency compared to constant mesh gearboxes. The gearbox has a simple design, making it easy to manufacture. Its mechanism is straightforward, making it easy to understand and maintain. However, the sliding mesh gearbox also has some drawbacks. Only spur gears can be used, which can make operation noisy. It requires more effort from the driver to engage gears manually. The gear teeth experience more wear due to friction during sliding. Replacing gears can be time-consuming and costly compared to modern gearboxes. Sliding mesh gearboxes were used in several early vehicles, including Alfa 12 HP with a 4-speed manual transmission, Fiat 6 HP, Mercedes 35 HP, Renault Voiturette. These gearboxes played a key role in the development of early automotive transmission systems. In conclusion, the sliding mesh gearbox laid the foundation for modern gearbox designs. While it is no longer used in contemporary vehicles, it played a pivotal role in the evolution of transmission technology and remains an important topic in automotive engineering. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more automotive educational content.